In this video, we're going to learn how to figure out the oxidation numbers for the different elements in a chemical compound. The oxidation numbers are the numbers that I've written here above each one of the elements. Now, if you want to learn more about what oxidation numbers are or why they're important, check out my video called What Are Oxidation Numbers? In this video, we're going to work through the process of how you figure out what these numbers are. So here are the rules that we're going to use to figure out oxidation numbers. Now, just so you know, every teacher and textbook has their own version of these rules, but they all work in pretty much the same way. So if you learn mine, you'll still get the answer right 100% of the time, even if these are a little bit different from your teacher's. I'm going to talk through a few of these rules right now, and then I'll introduce the rest just as we work through practice problems. The first is this: an element by itself always has an oxidation number of 0. Here's what I mean by that. There are a lot of chemical compounds that have just one element. That element is not combined with any other elements. That's what I'm calling an element by itself. So that's something like Cl2. It doesn't matter how many atoms of that element you have, just as long as it's only that element and none others. So Cl2, an element by itself, oxidation number of 0. Sodium, Na, by itself, 0. S6, just sulfur, nothing else. P4, phosphorus, and nothing else, 0. So that's probably the easiest rule here. It's always 0 for the oxidation state if you have an element by itself with nothing else. The other rule here is about monatomic ions. These are ions that are made of only one atom. So like this. For monatomic ions, their oxidation number is the same as their ion charge. So for K plus here, its oxidation number is going to be +1. For N3 minus, it'll have an oxidation number of -3, and Mg2 plus here is going to have an oxidation number of +2. Now keep this in mind, when we write oxidation numbers, we write the sign first, so plus, minus, and then the number after. This is the opposite of how we write ionic charges, so just keep that in mind. The charge might be 2+ on magnesium, but the oxidation number is +2. Now for the rest of these rules, we usually use more than one together. So I'll just talk about these as we use them in example problems. Here is our first example. KCl, we want to figure out the oxidation numbers of the elements in this compound. Okay, so let's take a look at our rules here. K, potassium, is in this column in the periodic table. It's in group 1A. So there's this rule that elements in group 1A are always +1. So that is potassium's oxidation number. Then we have Cl over here. That is one of the halogens. Halogens, usually -1, positive with oxygen. Well, Cl certainly isn't with oxygen here, so we'll give it a -1 oxidation number. Now I want to use this to show you a third rule. That's this rule right here. The sum of oxidation numbers for a neutral compound equals 0. KCl is a neutral compound here. It doesn't have a charge after it. So that means that the sum of these oxidation numbers is going to equal 0. And that's definitely true here. +1 minus 1 equals 0. We'll use this later on when we do other examples, but just keep that in mind. The sum of oxidation numbers for a neutral compound should always equal 0. MgO. Mg is in this column in the periodic table, group 2A, and group 2A elements are always +2. So there's that. Oxygen here, we have a rule for oxygen. It is usually -2. It is -1 in peroxide. H2O2 hydrogen peroxide is the most common peroxide. It's probably the only one you'll ever see. But anyway, this oxygen is definitely not in hydrogen peroxide, so it's fair to say that its oxidation number will be -2. +2 for Mg, -2 for O, and they add together to make 0 because this is a neutral compound. CO, carbon monoxide. Let's figure this one out. Okay, so C here, there isn't any rule for carbon. So we'll have to figure it out based on what we do know. Okay, so we do know oxygen. Oxygen is usually -2 unless we're in a peroxide, definitely not a peroxide. So we can safely say that oxygen's oxidation number is -2. Now, let's use this other piece of information that we know, and that's the sum of oxidation numbers for a neutral compound should equal 0. So whatever carbon's oxidation number is should add together with oxygen's to make 0. So we can figure out that carbon's oxidation number should be +2. -2 from oxygen gives us 0. NH3. Okay, N, there isn't any information about that. So just like in the last example, we'll have to figure out its oxidation number using what we do know. Here we've got hydrogen. There's a rule for hydrogen. Hydrogen is +1 with nonmetals and -1 with metals. So nitrogen is definitely a nonmetal, which means that in this case, hydrogen is going to have a +1 oxidation number. Okay, but there are 3 hydrogens. Each one of them has a +1. So what we have to do is we have to multiply this +1 times 3 for the 3 hydrogens, and that's going to give us +3. Now, let's keep this rule in mind, that the sum of oxidation numbers for a neutral compound should equal 0. NH3 is definitely a neutral compound. We don't see any charge here. So whatever nitrogen's number here is needs to add together with +3 to make 0. So that means that nitrogen here has to be -3. That adds there to get 0. So its oxidation number is -3, hydrogen's is +1. CaC2. So calcium here is in this column, group 2A, so we know that its number is always +2. We don't know what carbon's number is, but we can figure it out. What we do know is that calcium's number plus whatever carbon's number is needs to equal 0 because this is a neutral compound. It doesn't have a charge. That means that the total number on carbon is going to be -2. But there are 2 carbons here, so we have to divide this number between the 2 of them. So we're going to take this and divide it by 2 to get an oxidation number of -1 for each one, +2 for calcium, -1 for carbon. NO2 1-, check this out, it is an ion. So this is going to be a little bit different. In this case, the sum of oxidation numbers for a polyatomic ion equals the ion charge. So let's see how we'll use that here. Nitrogen, we don't know what its oxidation number is going to be, but oxygen here is usually -2. So we have -2 here, but we have 2 oxygens. So we're going to do -2 times 2 is going to give us -4 altogether. Now, whatever nitrogen's is, when we combine it with -4, we need to get not 0, but we need to get -1, because that's what the ion charge of NO2 1- is. So this means that we will have 3 plus 3 plus 3 minus 4 gives us -1, which means that the oxidation number here on nitrogen is going to be +3. HNO3. Okay, let's take a look at the rules. We got hydrogen. Hydrogen here is combined with nonmetals, nitrogen and oxygen, so that means that its oxidation number is going to be +1. Oxygen over here is going to be -2, but we have 3 oxygens, so we got to take this -2 times 3 to get -6. Okay, so now we have +1 from the hydrogen plus whatever nitrogen is, -6 has got to give us 0 because this is a neutral compound here. So that means that in this case, nitrogen's oxidation number will be +5. 1 plus 5 minus 6 equals 0. Now I'm going to start talking about some more challenging examples that use some rules here that are a little less common. ZnH2. Okay, zinc here, we don't know what its charge will be, but hydrogen, we have a rule for that. Now we've been used to hydrogen's number being +1 because it's been with nonmetals. But here it's with a metal, with zinc. So that means that its oxidation number is going to be -1. But we have two of these hydrogens, so it's going to be -1 times 2 give us -2. Since this is a neutral compound, whatever zinc is plus -2 has to give us 0. So that means that zinc's oxidation number must be +2 here. So we got +2 for zinc and -1 for hydrogen, because a hydrogen was with metal, so it has a -1 oxidation number. BrO3 1-. This is a tricky one, but it's pretty common. So Br, bromine, is one of the halogens. The rule for the halogens is they are usually -1, but they are positive with oxygen. So I'm not going to put 1- in here because it's with oxygen. So let's go to oxygen instead. Oxygen is usually -2 since it's not in peroxide. So let me put that here, -2. Now we have 3 oxygens, so that's going to be times 3 to give us -6. Now whatever bromine is, -6 has got to give us -1, because this whole thing is a polyatomic ion that has a charge of -1. So that means that bromine's charge must be +5. +5 minus 6 gives us -1. So this is an exception where the halogens, instead of having an oxidation number of -1, have a positive oxidation number because they're paired up with oxygen. Keep that in mind. ClF3. Okay, so here we have 2 halogens in the same compound. We have fluorine and chlorine. How are we going to figure this out? Well, this is one of these things that sometimes happens where fluorine combines with another one of the halogens. We're going to zero in on this rule first, that fluorine is always, always, always -1. So I'm going to put a -1 right there, multiply it by 3 because I have 3 of them, and get -3. Now chlorine, the other halogen, says that these other halogens are usually -1, but not always. They can be positive with oxygen. They can also be positive with fluorine here. So fluorine gives us -3. Chlorine must be +3 so that these can add together to give us 0, since this is a neutral compound, which means that chlorine's oxidation number must be +3. And it's +3 instead of -1 because it's paired with fluorine, which is always, always, always -1 no matter what. So that's how to work through these rules to figure out what the oxidation numbers of elements are in a compound. If you want a little bit more practice, I'm going to have another video with more practice problems. If you just are a little bit shaky on this, doing more and more practice problems is the best way to get good really fast.